Welcome to my project demonstration for the SteelBite robot. Today I'll walk you through the proposed design, show the TinkerCAD simulation, highlight how the sensors and actuators work together, and go through the Arduino code that makes it all function. So as you can see on the screen here, this is the TinkerCAD simulation of SteelBite circuitry. The link will be included in the description. You can see multiple components here, all connected properly to the Arduino Uno. Here's the IR receiver, which works with the IR remote here for operator control. Here's the ultrasonic distance sensor for obstacle detection. Here's a gas sensor for safety monitoring of gas levels. Here's a camera placeholder, just a photoresistor. Here are the two L2 930 chips for driving the motors here. And then the last component is the laser output LED, which is simulating the rust removal with various power levels. So the SteelBite robot operates by combining operator inputs with real-time sensor data. Driving the robot will be done with the IR remote here. The operator can move forward, backward, turn left, or turn right. And here we have forward, volume plus, right, backward, and left. Each button sends a unique signal that the Arduino decodes and translates into motor commands. There's a safety override. If no command is received, the robot automatically stops motors after a short time. The ultrasonic sensor over here, this continuously measures distance in inches. If an obstacle is detected, the operator can adjust the motion. This would be good for low light situations or with objects that are below potentially the blind spot of the camera. The gas sensor constantly checks for hazardous gases. If levels exceed the safe threshold, the Arduino disables the laser for safety. The laser system is also operated with the IR remote here. The operator can toggle the laser on and off. On is this up button, off is this down button. And then the power levels can be selected with the various numbers from 0 to 9. The Arduino translates that into pulse width modulation output for the laser pin. And then it has data reporting as well. So every few hundred milliseconds, the robot prints updates to the serial monitor, including distance, gas readings, laser status, and pulse width modulation levels. This way, the robot combines manual control with autonomous safety checks. So now we'll quickly go through the Arduino code. So the full program is quite long, but it's relatively simple, just quite a lot of variables and functions. But it is structured into relatively clear functions. So here we have our stop motors, which, as the name suggests, is part of the motor function. We have left forward, left reverse, right forward, right reverse, forward, backward, turn left, turn right functions. Those all pretty much do what the name says. This is for the distance reading. This is for updating the laser power levels. And this handles the IR commands from the IR remote. So this is just the setup, and this is the main loop that kind of gets everything going. Yes, so that is the code, and then we can watch the simulation real quick and preview the serial monitor. So it's printing out our distance in inches, our gas level, laser level, pulse width modulation. So here I can move forward. You can see both motors turning on. Right, it'll just be the right motor, and so on and so forth. I can turn on the power for the laser. So now the laser is on, and now I can change the level. And as I change the level, the LEDs will change as well. So thank you for watching the video, and I hope that you enjoyed. I hope that SteelBite integrates multiple inputs and outputs, balances operator control, and meets the requirements that are needed. Okay, thank you for watching.